Good afternoon and welcome to the Math Video Tutor. The topic of this course is Algebra 2. And I don't want you to get too afraid by the term Algebra 2. It doesn't mean that it's more difficult or really any more complicated. It just means that we're going to pick up where Algebra 1 left off, and we're going to study some topics that are absolutely crucial to your understanding of other math and physics and trigonometry, geometry, and things like that. And also I want to tell you that my goal in this course is to teach you what you need to know to excel in algebra. And in this case, in this course, Algebra 2. So I'm not going to cover every single topic. If you look in your book, I'm not going to cover every single topic in the book. I'm going to cover what I think are the most important topics. And I've decided what I believe are the most important topics based on tutoring hundreds of people and really helping people understand math. Okay. Secondly, I like to point out that most of the time during the video, my back is going to be to you. We're going to be working examples on the board. I'm not going to do a lot of lectures where I just bore you to death with a bunch of stuff. The way to learn math is to do it, okay? To sit there, to take examples and work it. So I'm going to teach you what you need to know to take examples and to work them. And I believe that through that, we will together learn algebra and hopefully get you to understand it. And so let's begin. The first topic that we're going to talk about today is linear equations, graphing, and things like that. And by the way, in the course of this video series here, if there's something you don't understand that I'm going over, it's probably because the material that we're talking about maybe was already covered in a previous course. So you might want to go back and get one of my other videos and other math topics if there's something I'm telling you that doesn't quite make sense. But my goal is to take it step by step by step so that no one gets lost. And that's my goal today. So again, let's get started with linear equations and talk about graphing. And we'll just go right to it there. The main thing to consider is it's very important in math to do what we call a plot. Okay, so let's just talk about the basics of really what that is. I'm going to draw a couple of lines here. Nothing too fancy about these lines. I'm just going to draw a line going this way, and I'm going to draw a line going this way. Okay, this is called a coordinate axes. And we have to use some mechanism to label these axes. So I'm going to call this the x-axis. I'm going to call this the y-axis. I mean, you could label these anything you want. This could be time, this could be distance, this could be pressure of some gas, this could be volume. I mean, they could be anything, but in algebra, you try to keep things general, and so this is x and this is y. Okay, so what we do is we put these two lines on the board here, and then we have to start labeling some things, okay? So I put a tick mark here. I'm going to say that's 1. A 1 here, that's 2. Okay, here's 3. Here's 4, okay? And again, on the y-axis, I can go 1, 2, 3. Of course, the numbers go on up to infinity. And likewise, for x, you have -1. Remember your number line here. So you have the negative numbers 2, -3, and so on. And these go to negative infinity. And then for the y-axis, you have -1, -2, and they go down from there. Okay? And in the middle, of course, because I've drawn it this way, this is 0. This is x equals 0 and y equals 0, right in the center there. Now, the only reason we label this thing is to help us plot things. You may have seen like the stock market or something like that. Like, I'll just draw a little example over here. Like maybe the stock market, the stocks go up and down. Plots are everywhere, okay? And in this case of the stock market, it might be time of the day and like the price of the stock going up and then maybe going down, okay? So plots are everywhere. They're very important. They're crucial to the understanding of algebra, okay? So this is a plot. Now, how do we use this thing? Well, in general, in order to use it, I need to define what I call, what we call an ordered pair in algebra. So what I'm going to do is I'm going to put two numbers on the board here. And just for fun, I'm going to say for this pair of numbers, I'm going to have 1, 2. Okay? When you write numbers in parentheses with a number, comma, then another number. The first number, okay, is always x, which is this horizontal axis here. The second number is always y, which is this axis right here. So you always write them in terms of x first, comma, y second. So it's very easy to use this. If you have a number, you take the first number and you say, okay, this is the x-axis. I'm going to go over to the number 1 because 1 is written right there. The second number is 2. So from this point, I'm going to count up to 2 and I'm going to put a dot right here. Okay, this is a point on this graph. Okay, x comma y, go over 1 up 2. Okay, it's pretty simple. If I have another one, let's say it's 3 comma 1. Let's make it interesting. 3 comma negative 1. Okay, well I got to go over 3 in the x direction, 1, 2, 3, and then down to negative 1. So I've got a point here. And I can label these points 3 comma negative 1. And I can of course label this point 1 comma 2. Okay, so that is the basics of really how you plot a point. Okay, that's really the gist of how you plot a point. And all you need to remember is that you have the x number first and the y number second. Now let's go ahead and use this a little bit to do something a little bit more like algebra. What we're going to do is we're going to try to plot a line. Okay, remember, or maybe you don't remember, but we'll go ahead and review it right now. This is an equation. You know, we just pretend this is Algebra 1 and you never heard of a graph here. If I write something on the board, y equals x plus 2, this is an equation for something. You know, it has two variables in it. The first variable is x, the second variable is y. So I want to find out what this looks like if I were to try to draw it here. Okay, and the way to do that is just to make a table. So I make a table here. I say, okay, that's the value of x. I draw a line here, and this is the value of y. In this equation, x is what we call the independent variable. And traditionally, that's how it usually is written down in algebra. It's the number that you kind of allow to change, okay, along this axis here, and then y is just simply going to be a function of x. It's going to be dependent upon x. So instead of talking about it, let's just work on it. Let's just say, you know, we pick a few numbers here to see what happens here. Let's pretend x is equal to 1. If x is equal to 1, and I put 1 over here, well then 1 plus 2 is 3, so y must equal 3. When x is 1, y is equal to 3. And this is going to become, this point is going to become a point, just like we had just talked about just a minute ago. I'm just going to list a whole bunch of these points and we're going to draw them here. Now let's say x is equal to 2. If x is equal to 2, then y is equal to 4 because 2 plus 2 is 4. And then just continuing here, if I put x equals 3 in there, then 3 plus 2 is 5, like that. So now I have 3 points. This is a point, 1 comma 3, 2 comma 4, 3 comma 5. Let's go ahead and draw those. 1 comma 1, 2, 3. Okay? And let's say we have a point 2 comma 4. 2 is x, 1, 2, 1, 2, 3. 4 is going to be up here because it's kind of off the graph here, like that. 3 comma 5 is a perfectly good point, but if you look at it, 3 is over here, 1, 2, 3, 4. Well, 5 would be just off the chart here, so we can just pick another number that's convenient. We can say 0. We can say x is equal to 0. Okay? 0 plus 2 is just going to be equal to 2. So here's another point, 0 comma 2. Again, we went 0 on the x-axis, and we counted 2 here. Now we have 3 points, okay? And we can just even pick another one to make it even more clear. If I pick negative 1 for x, negative 1 plus 2, remember back from your algebra, is just equal to 1. Okay? So if I go to negative 1, I'm going to go up to 1. Again, negative 1 on the x-axis, 1 on the y-axis. Now notice what I have here, and I'll make it clear for you. I have, now my drawing isn't exactly perfect, but I have essentially a straight line. Okay? This line goes up and down forever, okay? And it's defined by all these points. So the easiest way to graph any equation is you just make up numbers for x, plug them in, you get numbers for y. Okay, simple as that. Notice that this line, again, is a straight line. There's no curves in it anywhere. Notice that it has a certain slope. Okay, notice it's kind of like this. I mean, the line could have been more this way, could have been more this way, but it has a certain slope. We're going to learn about all these things in detail in a minute. I just want to point a few things out. So that's an example of plotting that first equation, and we're going to do, several of these things here. Now, one thing I want to do before I go on, though, is I want to redraw my graph, because you will find as you do this stuff over and over again, you will find that it becomes very, very useful to compress your axis a little bit here. And all I mean by that is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5. Now notice I'm just picking numbers here. I mean, I could make them go out to -10, -15 if I wanted to. It doesn't really matter. And these axes, these go on to infinity. I just wanted to draw with a few more numbers here so we could be effective. Let's try another problem. Let's say our equation is y is equal to 2x. Okay. Again, all you do is you draw a table. You have an x column, you have a y column. Okay. And let's just say here that x is equal to 2. Well, when you put 2 in here, 2 times 2 is 4. Okay, let's say you have a 1 here. Again, you put a 1 into x, 2 times 1 is 2. And let's say you have a -3. 2 times -3 is, again, -6. Now, again, you have 3 numbers, 3 coordinates, 3 points on this map here, and we're going to try to figure out what the line looks like. So for the first one, this one right here, x is equal to 2, so I go 1, 2. Y is equal to 4, so from this point I go 1, 2, 3, 4. Here's a point right here. Okay? For this one, x is equal to 1, y is equal to 2. Go up to 2, 1, comma, 2. -3, comma, -6, -1, -2, -3, and then I'm going to go all the way down to -6. I'm going to put a point down here. And you can kind of see, I mean, it's not 100% accurate because it's kind of hand-drawn, but you can kind of see that that forms a line that looks something like that. Okay? And it has a line like that. Again, it has a slope that's maybe a little bit steeper than the one that I just did a minute ago, and so on. But it's basically like that. Now notice there's a lot of points in the middle here that I haven't drawn. I mean, we could go figure those points out if we wanted to. I mean, we could do that. We could go -1. What happens if x is equal to -1? Well, 2 times -1 is -2. So -1, comma, and you go -1, -2. It's going to be right around there somewhere. I think my graph's a little bit skewed, but that's essentially it. Okay? So let's go ahead and erase this particular line. This is -1, this is -2, -3, like that. Okay? Okay, and we'll do something a little bit different. What if we have something like y is equal to x over 2 minus 2? Okay, x over 2 minus 2. Well, again, we can pick some random numbers. Let's say we have x and we have y. Okay, let's say we have x is equal to 0. It's a pretty easy thing. X over 2, if x is 0, 0 over 2 is just 0. So you're just going to get -2, because this term goes to 0 when you do that. Let's say And notice, I'm picking my numbers intelligently here. I could put x equal 1 here and just see what happens, but I'm going to have 1/2 minus 2. I'm going to have a bunch of fractions. I want to try to avoid that. So I can pick 2. Remember, you can pick any number you want for x, and it's going to work out just fine. You just plug it in and you get the number for y. So let's put 2 in there. 2 over 2 is 1. 1 minus 2 is -1. Okay? And again, I'm going to be smart and I'm going to pick 4 because I know that 4 divided by 2 is 2. And then 2 minus 2 is 0. Okay, so let's plot that guy. Okay, 0, comma, -2 is right here. Okay, 2, 1, 2, comma, -1 is somewhere right here. Okay, 4, comma, 0, 1, 2, 3, 4, comma, 0 is right here. And again, it's not perfect because it's hand-drawn, but you can see that this is a line, and if you were to write this on the graph, the equation of this line is x over 2 minus 2. Okay? So it's not too bad. And really it's the same process, over and over again when you do it like this. And again, I'm teaching you a few different ways to graph equations. The easiest, most simple, most bulletproof way is to just write the equation on the board, write down an x and a y column, and fill up the numbers of x, with whatever numbers you want, plug it into the equation, get a bunch of numbers for y, and then turn around and just plot all those points, and everything's going to work. And it's going to work for you every single time. But as you've seen, it takes a little bit of time to sit here and write down x and y, and write them all down and plot them. Okay, that takes a little bit of time, and you're not always going to have a lot of time. So I'm going to teach you a few ways to speed this process up, and I think you're going to really be happy with that, because I don't know about you, but for me, anytime I can make my life a little bit easier, speed things up just a hair, I'm happy. I think that's a good thing. Okay. Again, so the first thing I'm going to do is I'm going to draw my coordinate graph again. So, and again, I'm doing this stuff over and over again, somewhat for your benefit, so that you can kind of see what you do whenever you start a problem. Okay. So let's say I've got, this is 1, 2, 3, 4, 5, 6, 7, 8, and let's say this is 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, and so on. Down to -8. Again, I have different, here I'm going to 8, and the last one I went to 6, but it really doesn't matter. This is -1, -2, -3, and you know what? Graph paper really helps for this. If you have some graph paper, you don't have to draw these things every time. You just kind of write your numbers down. Let's write, an equation a little bit differently. Let's say the equation I'm trying to plot is x plus y is equal to 7. Now, this looks a little bit different from before, because in the other problem, I had y off to one side, y equals something. Okay. Well, I could do that here. The brute force, the absolute easiest way to do this problem would be to turn around, solve this equation for y, which you would do by just subtracting x from this side. So you would get 7 minus x. That would give your equation for y. Okay, and then you can make your table of x and y, points, and you could plot them all. But I'm going to show you an easier way. Think about it. You only need 2 points to define a line. Only 2. We can plot 10 of them, but they're all going to be on the same line. If you have a point here and a point here, those 2 points are good enough to define a line. So how can I find the easiest 2 points to figure out here? I'm going to show you a trick. If I pick x is equal to 0, if I just put a 0 in here, what I'm trying to figure out is, if I put x equal to 0, what is y going to equal? 0, comma, well, if I put 0 here, y is just equal to 7. That's all that's left over. Once 0 is here, y is equal to 7. So that's 1 point. 0, comma, 1, 2, 3, 4, 5, 6, 7. That's a point up here. Okay? Likewise, if I put y equal to 0. Y equal to 0, which is a little different than what we've been doing before. Then x also is equal to 7. That's pretty cool, right? I've immediately gotten 2 points that I can use. Well, let's figure this one out. X is equal to 7, y is equal to 0, so I just put it there. Now, this is a line that can go right through here. And again, I could have solved this and made a bunch of points up, and all those points would have fit on that line, but why do that? Okay? This solution technique, or plotting technique really is what it is called the intercept method. You basically are trying to find the two intercepts here. Remember, this is the x-axis and this is the y-axis. This point right here is called the x-intercept because it's where the line intercepts the x-axis. This point is called the y-intercept because it's the point where the graph intercepts the y-axis. So let's do another one of these. It'll make things, I think, a little bit simpler to kind of just see some problems over and over and over again. Okay, so let's do that. Next problem is, let's just say we have 2x plus 3y equals 12. Okay? Again, we could solve this problem for y. I mean, we could subtract 2x and then we could divide by 3 and we would have an equation that we could use to plot a bunch of points. But it's easier just to find the x-intercept and the y-intercept. So what I'm going to do is I'm going to say, what happens when x is equal to 0? If x is equal to 0, this term goes to 0. 2 times 0 is 0. Okay? I will be left with 3y equals 12. Okay? And you remember from elementary equations, really, that if you have an equation like 3y is equal to 12, and I'll just write it over here, 3y is equal to 12, which is what you'll be left with here, you can find y by just dividing both sides of the equation by 3. Okay? So then y is just going to equal 4, because that's what you get here. And you can kind of do this in your head. If you get rid of this term, you're left with 3y is equal to 12. You divide both sides by 3. Okay, so y is equal to 4. So that's 1 point. Now let's say I want to find out what happens when y is 0. Okay? If I put y is equal to 0, this term drops away and I'm left with 2x is equal to 12. 2x is equal to 12. And just think about it. To find x, you just divide by 2. And 12 divided by 2 is simply 6. Okay? So let's go find our y-intercepts. The first point is 0, 1, 2, 3, 4. The second point is 6, 0. Again, it's a point on each axis. And I can draw that line like this. Okay? So I've graphed these equations in a really easy way, which is just using the intercept method here. Okay? So, you can just pick a number, say that x is equal to 0, find out what you have, and then see that y is equal to 0 and find out what you have. Okay, let's do another one. We're just going to practice this a little bit here. Let's say 3x plus 12 is equal to 4y. Now, this is really this very, very similar problem to the last one, okay? It's just that things are rearranged a little bit. But you can do the same thing, okay? I'm going to say, okay, what if x is equal to 0? What do I have then? Okay, if x is equal to 0, I'm going to have 12 equal 4y. So I divide both sides by 4. I'm going to get 3. Y is equal to 3. If I say now y is equal to 0, I'm going to be left with this stuff. Now this one I'm going to kind of help you out a little bit here. I'm going to have 3x plus 12 is equal to 0. If I set y equal to 0, that's what I'm going to have. Okay. So what I can do is I can move this 12 over to the other side. 3x is equal to negative 12. I just subtract 12 from both sides, so it goes away over here, and it pops up as a negative over here. X is just going to equal, I divide both sides by 3. Remember from solving equations. Divide both sides by 3, so this is going to be equal to negative 4. Okay? So, the answer is negative 4. Now I've got my 2 points here. The first point is 0, 1, 2, 3. The next point is negative 1, 2, 3, 4, 0. So this graph looks more like this. Okay? And again, I could have solved this for y, okay? And I could have made up a bunch of numbers. I could have plugged them in, and I could have seen how they would have looked, okay? But, you know, it gets a little bit more messy when you have, you know, when you do that, because the equation isn't quite as simple. This is very fast. You just put in 0 for x, see what you get for y. Put in 0 for y, see what you get for x, and then go from there. And again, anytime through here, as I go through the math to solve some of these things, if you find out that you don't quite understand exactly what I'm talking about here and exactly how you find the answer to some of these things, you need to go back and pick up my previous video, which is the Algebra 1. It's actually called the Math Tutor, Video Tutor Fractions Through Algebra. That course will take you from basic addition all the way up through everything we're starting to do here so that everyone is with us. But I also am going to try to keep everybody up to speed as we go here. Okay. Let's do one more, and then I think our graph will probably be cluttered enough where we'll just start over here. And we'll take a little bit more difficult example. We'll say 2 times, we'll say x plus 2 minus y is equal to 4. You'll find in the study of algebra here that the books will typically just try to put the problem in a more complicated looking form to kind of scare you a little bit, and that's a common thing. You just need to not be frightened by that. Just push on and just think logically on what's the best way to solve this, and then I think you'll end up with something there. What I'm going to do in this case is, instead of just starting to put in 0 for x and 0 for y, I'm going to simplify this expression a little bit. So I'm going to distribute the 2 in. Remember, when I distribute in, it goes into both things. So that gives me 2x plus 2 times 2 is 4 minus y equals 4. Okay? And also I'm going to move this 4 over here by subtracting it. Okay? So I'm going to have 2x minus y equals, and I subtract 4 from both sides. 4 minus 4 is 0. So it basically drops out. Now I'm left with something that I've been working with all day long, with just a few steps of math. Now here's a time to step back and look and see what I can do next. What I can do is I can further simplify this and say, I'm going to go ahead and move this y, I'm going to move it over here. So it's going to give me 2x is equal to y, because I add y to both sides. So it goes away here, and I get it over here. And I can just flip this around and say y is equal to 2x. Okay? Y is equal to 2x. And this is a little bit of a different equation, and so what I'm going to do here is the same way, just for practice, that we did last time. I'm going to say, well, if I've got x and I've got y, I'm going to pick some numbers. 0 is always a pretty easy number, so 2 times 0 is 0. 1 for x is always an easy number, so 2 times 1 is 2. And I can go on and do 3 if I want. I can pick x is equal to 2. 2 times 2 is 4. So I get a family of numbers here. 0, 0 fits right here. Okay? 1, 2 fits right here. 2, 4, 2, 1, 2, 3, 4 fits right here. And then again, you can see that there's a line here like this. Okay? So I think that that's pretty good for right now on this stuff. And what I'm going to do next is I'm going to show you something a little bit different. A few different types of linear, equations of a line here that are a little bit, I won't really want to say tricky, but just a little bit different. Okay? Because I really think it's important that you get exposed to this. And these, when you really think about it, you'll see in just a second, are even easier than the ones we've been working on just a few minutes ago. So I'm going to draw my line, x and y, and I'm going to say 1, 2, 3, 4, 5. And again, 1, 2, 3, 4, 5. And we'll do -1, -2, -3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay? X and Y. Now, these equations that I'm going to give you here in the next little bit are really, really interesting. What if I give you an equation that looks like this? Y is equal to negative 5. Now, you might look at that and you might say, that is totally different than everything else we've been working on. And it is. There's no X anywhere in here. Okay, there's no X anywhere in here. And you might think, well, how in the heck do I do that? I can't find an x-intercept, a y-intercept. I can't I make a table of x and y because I won't know what to do. Okay, I'm going to show you how easy it is to think about these things. Okay, when you see something like this, I want you to think about, what does it mean? Okay, what it means is y is equal to negative 5, no matter what value of x there is. So I could make a table, and I could put x is equal to negative 52, positive 39, and go on and on and on with all these numbers. But this equation is telling me that it doesn't matter what x is. Y is. So if you were to plot that, what you would have is a line that would go horizontal like this, like this. This is the equation y is equal to negative 5. This is the equation of that line. Notice that it is a line. Okay, it does go horizontal there through this y-intercept here. We did find the y-intercept actually, which is negative 5. Okay, it just turns out that the slope of this thing, it doesn't go anything other than horizontal. So really, when you look at it, the slope is kind of like 0. Okay, and the way you can really think about it is, when you have something like y is equal to negative 5, is that x is the same no matter what value of x. You're always going to have negative 5 as your y value. So you draw it like that. Another example would be x is equal to 4. Okay, well, this means that x is always equal to 4 no matter what value of y there is. So this equation is going to look like this through the number 4. Okay, and when you think about it, it makes sense, because you're trying to make a plot of numbers like this. Okay, what it means is, if x is equal to 4, it doesn't even matter what y is. Okay, I could put y is equal to 3, y is equal to 9, y is equal to negative 2. It doesn't matter. X is always equal to 4, so it always looks like that. Okay, so the equation of this line would be x is equal to 4. Okay. Another one that would be interesting to look at is y is equal to 0. Okay, and again, what this means is, no matter what value of x there is, y is always equal to 0, which means it's always got to be over here. And it's going to be difficult to draw here, but I'm just going to make this extra dark, like this. Okay, this is the equation y is equal to 0. It just goes right along the x-axis here, because no matter what value of x I have, y is always equal to 0, which is exactly right here. Okay, and that's interesting. What we can do then is we can erase this, and we can erase this. Okay, we can do one more problem here. What if I had 3 times y minus 2 plus 2 equals y? Okay, this is totally different than anything we've looked at. There's no x in there. There's a y here and a y here. My best advice, and again, in a situation like that, when it's kind of complicated looking, is just try to simplify it. See what it gives you. So if I have this, I'm going to distribute the 3 in. That's going to be 3y minus 3 times 2 is 6 plus 2 equals y. Okay? I can simplify this because these are just numbers. 3y minus 4 equals y. I just added these two together. Negative 6 plus 2 is negative 4. Okay? And then what I can do is I can move this 3y over here. So I'll be left with negative 4 equals, and I'm going to have I'll just write it out. Y minus 3y. So negative 4 is equal to negative 2y. Okay? I just moved the 3y over, subtracted 3y from both sides, so I got negative 2y. And then I can just simply divide by negative 2 here, and that'll get y by itself. So y is negative 4 divided by negative 2, so y is equal to 2. Because remember, negative divided by negative gives you a positive, so y is equal to 2. Now this is an equation of a line, and we've already done one very similar to it, and it's going to look something like this. No matter what the value of x is, anywhere along here, no matter what the value of x is, y is always going to be equal to 2. So the equation of this line is y is equal to 2. Now notice this looks a whole lot different than this. That's just, your problems are going to just do that. They're going to try to make it look a little bit more complicated than it is. That concludes the first of the lessons in this course on Algebra 2, graphing of linear equations. We're going to cover a lot of different topics of equations and inequalities and other topics, and we'll just proceed from there. Thank you.